Hello, I am Monsieur. Howdy doing? Um, this is the Panda3D program that kind of demonstrates some collision kind of scenarios that you would set up these really basic tools that you would want to use if you're trying to make things collide with each other. So, um, I have two models in this program. Um, one of them is something that can be moved, and the other one is just something that can be collided with. Um, if I start from the beginning of this class that runs the program, after I start up the window, I use these two commands to load this model that I want to collide with. After that, there's some more important stuff that comes after these key kind of representations. This variable is used for checking to see if any one of these buttons are down, and I use that to kind of detect input so you can see when you want to move something. This variable is one of the components that is used for the collisions. The collision traverser is something that allows you to use the data that's kind of given by the shapes and like geometry that models give you, or the shapes that you kind of use by Panda's built-in collision shapes. When you use the collision traverser, you have to add kind of registered shapes to it. So after you create it, it doesn't do anything by itself, but the collision handler queue, which is here, is also something that you need to use with it. The models that kind of load here are just one model is the model that I use for that I move in the program. So after I load it, I want to give it a collision kind of setup, and collision nodes are what I use here. The collision node itself doesn't really have any shapes in it, so it doesn't necessarily know where things are going to collide with each other or what shape they are. So I use the collision node to give kind of the collision awareness to some other like component in a program. So I attach the collision node variable to this model that I loaded earlier, which is directly above it. And then to give it the shape that I want to collide with, I use this, which is a collision sphere. And after creating the collision sphere, I add it to the collision node. And collisions can be calculated by adding them to the traverser. When you add a collider to a traverser, it lets the traverser know that this like shape or this collision data is something that you want to process and have be in the same space as other things that you would want to process. So adding one collision node to a traverser can be added with other nodes that would be added to it too. So you can have more than one kind of collision node for something, or inside a collision. You can also have more than one shape inside a collision node. And the second variable here is in this situation, it's what the traverser kind of lets the program do with the collision information. So with this variable, the queue kind of has information about all the collisions that the traverser processed, and you can kind of get information about it and then try to make your own system about how you want to respond to two things colliding. So what I did is when there are collisions, then this code is something that's executed for the model that I want to move. So for a specific kind of interaction or collision, the entry that was detected is this variable that I set up, and I get the point that two objects collided at, and then I add some height to it. So an object will be kind of above the point that it collided with something. If you set an object to the point where it does collide with something, then it'll and it might be colliding like inside of the floor with it, like in the center, because the position of something is in its center and not on the bottom of it. So let's take a look at what this looks like so far. Here's the model that I move, and this is the collision sphere that I defined. When I try to move downward, it won't go through this object that I have, because when the collision is around, then the position of this model is set to a little bit above this object. I guess there are some other important parts of the program, like these keyboard kind of these kind of like buttons on the keyboard that you're pressing. This setup kind of has the button or key representations of something, and I use these with this variable that's in the application, which is the mouse watcher node. And when I use these two together, then I can check for a representation of a button that's being pressed. So that's how you can detect input. I also have these kind of commands here. It can be used for like debugging information. Collide show is the collision node kind of displaying information in the scene about how it's colliding with things. Let's see what happens when I turn that off. Okay. And this debug command is for the model. So let's see what that does. Doesn't look like it does anything in this situation. I don't know. Oh, wait. Right. Show for the node paths is a different function than, well, not different. It does something different than the collision show method does. Can use show and hide commands for a node path to kind of display it and kind of make it invisible for a scene. So maybe node paths or models themselves What? What? I didn't know Vocaloid was in this universe. What? Oh no. Um. mm, Um. So I guess the models don't necessarily control the debug information of the collisions that are like contained inside them. The collision nodes might do that themselves. Um, Also, the collision traverser has has like a debug command here. So this might give some additional information that, in addition to the collision nodes that are part of the objects in the scene. Yeah. Looks like the difference is this time the display isn't showing the actual points that things are interacting. It's just showing the collision shapes themselves. Yeah. And the other part of this program is this movement movement situation that I have here. This code is executed like several times every second because it's called every frame. So the variables that I defined earlier that are the keyboard buttons and the function to check if something is pressed or used here. And when input is detected for a key, then I move the model. And the models can be moved relative to themselves if you put the name of something or the name of like the model that you're moving in the set position function before the position that you're setting it to. Also, this is something that I tried to make execute every 1.2 seconds. To do that, I have this variable that I set to 1, and then since this is executed several times a second, it won't execute more than once. I think, because after it's executed once, it has to wait 1.2 seconds before it can be called again. Because when it's executed the first time, it's set to 1, and then when it's called the second time, within within a second, then it's going to wait before it can set it back to 0. And this might be called like several times, but it still has a delay before it can be moved again. Yeah. I hope you found this video informative. Thank you for watching. Thank you. Goodbye.